Yo, yo, what's up, everybody? Welcome back. Advent of Code. Day 6 and 7? 6, 7, ha 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 ha. I'm 11. But anyways, we missed a day yesterday, so we have to catch up. If I remember correctly, we are an elf and we're trying to go do our job in the North Pole. Day 1, we enter a pass. We figure out the password to enter the secret base. Day 2, I think we fixed some problems in the gift shop where some child messed up all of the database. Day 3, I think we fixed an escalator so we could get down to paper sorting or like the printer room. Then the printer room, we had to optimize their process a little bit to free up a forklift to bust through a wall. Then we busted through the wall and went into the cafeteria. And in the cafeteria, they were confused about what food was fresh. I don't know if that was relevant to us trying to get somewhere or if we were just being nice and helping out our pals. I think we were just helping out our pals. So I guess we'll see what happens day 6. So we helped our elves in the kitchen. We're taking a break, helping them reenact a movie scene when I overenthusiastically jump into the garbage chute. Oh, I fall down the chutes. That's what this little picture here is. Nice. A brief fall later, I found myself in the garbage smasher. Unfortunately, the door has been magnetically sealed. As I try to find my way out, I am approached by a family of cephalopods. They're pretty sure they can get the door open. What the fuck is a cephalopod? Am I supposed to know what this is? Why are these things in the trash? Why are there octopus in the plural of octopus? Octopi? Is it octopi? Octopi versus octopuses versus octopods. Okay, why are there octopi in the garbage? They're pretty sure they can get the door open, but it will take some time. While you wait, they're curious if you can help the youngest cephalopod with their math homework. Why is this hyperlinked? Because in 2021, they had... Okay. Weird. Cephalopod math doesn't look that different from normal math. Oh, they're gonna do some, like, base 8 bullshit, right? Is that why? The math worksheet, your puzzle input, consists of a list of problems. Each problem has a group of numbers that need to be either added or multiplied together. However, the problems are arranged a little strangely. Oh, they seem to be presented next to each other in a very long horizontal list. Okay. Is this, like, RPN, like, reverse Polish notation shit? I always say octopussy. Yeah, I said that and then immediately was like, wait, I shouldn't have fucking said that. Each problem's numbers are arranged vertically. At the bottom of the problem is the symbol for the operation that needs to be performed. Problems are separated by a full column of only spaces. Sure, so like varying spaces, but each column is like padded. Like we're going column by column, I guess. So 123 times 45 times 6, 328 plus 64 plus 98, 51 plus 38, 87 plus 215. Interesting. If there works, cephalopod students are given the grand total of adding together all the answers to the individual problems, so you calculate them all, and then you actually do the work. Of course, the actual worksheet is much wider. Holy schmoly. Interesting. So, obviously, the easy solution to this is you just make a list of each set of numbers, and you then like get the operation at the end for each column, add them up. It does seem a little silly to have to store the entire content of the file in memory again, right? I would like, if there's a way to avoid that, that would be nice, right? Maybe the answer here is if we pre-processed the file such that it was row-wise, that would be nice, but that might be cheating. I guess even then, like pre-processing should be part of the how do you say this? It's like the same problem, right? You still have to like get a whole column. So I think that what I would rather do is I would almost rather rip the file multiple times, but I guess like memory-wise, that really sucks. Right? Like you can't really skip skip entire rows that easily. That's not like trivial. And the way that the data is laid out, it's like you naturally want to be reading it row by row, because like that's the way it's aligned. Do you want to come up with a solution yourself, or do you want to can we come up with ideas? I'd prefer to do it myself, I think. Okay. So I guess is the problem just like formulated in a way that makes this like fucking hard to do, like hard to do efficiently? Right? The right answer is that this stuff isn't laid out in columns like this. I guess you could. Is it like aligned in any way? Like, are the columns arbitrary width? Because if they're kind of like padded such that they line up with the next columns, like that you could do something with that, right? You could then at least have indexes into where each column starts, and then you could rip it one list at a time. However, I think that would still be slow. Yeah, I guess the answer is okay. I want to imagine that this list is so large that putting it in memory, like reading the whole thing into RAM, is unreasonable. That's kind of like the problem that I want to play with, because I think that's more fun. And so is there at least a way that as you're sequentially scanning this stuff, you can like pre-process parts of the list, right? I think the answer is probably the answer is probably that you either have to read entire lines, like each line has to be either read for however many columns there are, or you have to store buffer stuff in RAM. I don't think you have a choice either way. Okay. Then in that case, I guess we will just put everything in RAM the easy way. I guess we'll just do it the easy way and then be sad. Okay, fine. What are we doing? We are... If you read row with operators, you can find out the width of each column, I think. Oh, wait, okay, let's... Why do you think that? Because you think that they're aligned such that the operators are always lined up? Oh, that does solve the problem a little bit. If that's true. Let's try to confirm that. That would be interesting. So let's read the input. And let's get the maximum width of each column, or at least like the start, like the range of start and end positions of each column. Maybe that's what we do. Day 6 input text. So if we did something like we need a reader buff, and we do get one of these guys. Like, I understand that the columns are variable width, but maybe each column is like aligned with itself vertically. We could probably check that. If it can only be plus or mul, you could just do both and choose at the end. That's not crazy. I do like that solution. That's pretty funny. Cause yeah, why not? I agree. I like that. I like that as a hack to fix it. But in fact, I think I like that as the solution. You're a genius. Yeah, you can just do both. I like that. That solves the problem for me. I'm very happy with that. Okay, let's just do that. Sorry for whoever said, can we give you the answer? And then I said no, and then this guy just gives me the answer, and I'm like, fuck yeah. Okay. Columns. So can we do like sums buff is probably something like this. Are all numbers positive? Looks like it. Sums is I don't know. Array list of U64. And can we do moles? Okay. So I guess we rip this once to initialize the buffers. So we go like, Holagus, thank you for the prime. What day are we on? We are on day 6. Okay, we do a little read take delimiter exclusive. Do we do row by row? I think so, right? And then we just have to make sure that this buffer is big enough. Surely 8,000 characters is enough. But if it's not, then we have a problem. We could also scan until, like, I don't think that the reader interface has a way for us to, like, scan until one of many. I don't think. Take. Yeah, I can't do something that's like read one, like continue reading until one of many, so we'll just do it this way. Error end of stream. I guess we on the first row we don't expect that. So here we go for what? Var row iterator is split scalar on row with a space. I don't know how if this returns like empty strings. It will return empties, which is a little annoying. A little annoying. But that's okay. I think that we can figure this out eventually. Num if num len is equal to 0, continue. I can do it with reader fill more. True. Yeah, I guess that is kind of nicer, what you just said. I do like that better. Reader interface fill more. So we probably do this once at the front. And then we're like, we look at the buffer, stood mem index of none, probably. And we're looking for none of space and new line, I think. Something like that. Like this. Something like this. And then we get the, I guess it's like buff is this. Oopsies. And then we go like, or else, reader fill more. And go again. And then here we need our like exit condition. But whatever. Whatever. Okay. Then here, this is start index, and then I guess we need like the end index is index of scalar. We're looking for index of any, I guess. Something like this. Something like this. Then what? I guess this stuff needs to be a like function of some form, but we'll get there. And then we go like const num is I kind of want to like read. I kind of want to consume like the space in the new line as well. I think I kind of want something like this. Num reader. So this guy holds like inner of stood IO reader like this pointer, and then I want to go like eat like get number or something. I don't really know what we're doing here yet. Maybe this is just a function that takes one in actually. And I think I want this to return like delimiter as well, like number. So I kind of want this like or like red number, retrieved number, and I want this to be like in here. I want to say what the delimiter was. You know what I mean? Like new line space, and then I want to get like I guess here like data like number maybe even as like a usize maybe that seems reasonable, and then we can kind of do this stuff here. So I think that we should assume this is a number, or at least like assume we're or like at least assume we are at the start of a like non-white space character. I think that's what I want to do. And then I think that I want to do like index of any on our buffer. And this is maybe nullable, maybe. Definitely errorable. So this is our buffer like this. We're looking for any of space or new line at the beginning. So this is the like num end, and then this is like next num start. Something like this. This is probably like a while true type shit. I don't know, because here, if he doesn't find anything, it's like try our fill more. Okay, and then I think that's fine. And then continue. Something like this. Then we're looking for the same shit, but we're looking for where it's none of them. Yeah. And if it doesn't find this, I think we do... I think we need to... I guess if we can't find the next number start, that's not a problem. So maybe this is optional. And then we go like if next num start. I guess we use like the length of the buffer otherwise. And then I was gonna say, because then we can just kind of do like a throw out all of these bytes, like mark them in the reader for like we're ready to go. However, in the case where we've kind of like aligned our buffer on the in between words, it means that our constraint that we're starting on a number is no longer true. So I guess that the answer is we have to assume that we're in a gap. So here we have to go like num start here. And then we have num end from num start onwards or whatever. And if he can't find one, he tries to fill more. If he can't find the end, he also tries to fill more. Why can't you go line by line and use tokenized space? I don't know. In my mind, I like the idea of not having to pull a whole line in at a time. That was what I was trying to avoid initially. And I guess we want to look at like buff at num end. We look at this thing, and if it is a space, our delimiter is space. I don't know, something like this? Something like this. Delimiter is a delimiter equals this. And then if it's a new line, it's new line. Otherwise, it is unreachable. Cool. And then we return here. Delimiter is delimiter. And num is try_stood format parse int of buff from num start to num end. Cool. Sure. So then we can kind of start here, and we can go while true, get number on reader interface, I guess. And then we can say something that's like retrieved is this if retrieved delimiter is equal to new line. We break, we finish the first line. Otherwise, I guess no matter what, we are kind of putting in the number here. And I guess this guy we want to be U64 actually. Here we need to specify that's U64. Cool. And then we do this again, but we don't have to append anymore. Now, once we finish the first line, we do something like sums at index. Like this. Yup. And then we have mols index times equals retrieved num as well. Wonderful. And then if we get to a new line, index is equals 0. Else index plus equals 1. Okay. That feels like something. That sounds kind of fun. I actually did today's problem with Zig just to try optimizing the Zig SimD. It was got to be blazingly fast. Hell yeah, that sounds fun. That seems like it might do something. Now, eventually we're going to get to the point where it's not a number, right? So, I think, let's just see what happens when we get there. Let's also get our day 6 input. Maybe we'd start with the example as per usual. Day 6 input example. Zig run day 6. Open file. He's like, yo, you forgot this guy. Here, he's like, yo, your reader has to be variable. So true. Here he's like, parse int, you need to say what base you're in. So true. And then append is append bounded. Array list needs to say items here. Okay. I guess technically you don't even need you don't need this first iteration. Technically, as long as this buffer's big enough. Uh, yeah, I think that that's kind of just useless. Because you can kind of just do this. And as long as these start at 0, 0 and 1 respectively, then I think it's fine. Yeah. Then at the end, we're getting to invalid character, of course. So here, I think we look for error invalid character break, else return E. Yeah. And then now we can kind of assume that we're on get character, or like yeah. Now we kind of want something that's like while true, get operation or something. If we see a new line, well, I guess we kind of can. We can kind of just say like, I don't know, reader interface, read what? I don't know. Take take I don't know. Reader buffered, I guess. And here we're looking for index of any of star plus, I guess. Or else this guy. And if we have a end of stream, we're done, I think. And then we switch on op. And if it is a plus, we print, I guess, the sum. I guess we just print the number with a space. So this is like sums at index times is moles and else is unreachable. Okay, and so then we should be able to just do like index equals 0 here and index plus equals 1. All right. Bad news, unreachable at 91. So we're seeing something else. What are we getting? Up is this. How do we fuck this up? Oh, because it's a fucking number. Oops. Oopies. Okay. Bad news, bears. We are not getting out of the loop somehow. How is that happening? Yeah, wait, what the fuck is going on? What the fuck is going on here? Because shouldn't this guy break out when he can't find any more timeses and pluses? But instead, he's ripping a bunch of zeros. Right, so he should be seeing like this. This. Oh, I'm not tossing. I'm probably not tossing. I'm probably not tossing. Still no, huh? Why? Does buffered not include the toss position? Buffered goes from seek to end, and toss increases seek, right? Yeah. So wait, what's the problem? What is the problem here? Stood debug print op is this. Maybe we print his position and see what's happening. Because we must be missing something. He is just the 0th position all the time, which makes maybe no sense. Opposite index, maybe toss op +1. Yeah, I guess that is true because yeah, you're right. You're right. Much better. Well, now we're missing one? What the fuck? Plus times plus. Day 6 plus times, or this should be times plus times plus. We're skipping the first one now. Confusing. Yeah, it seems like we're missing the first character. This should only happen if we successfully parse. If the number doesn't parse successfully, then we shouldn't consume stuff. I think it's something like this. Yeah, there we go. That looks way more reasonable. Yeah, here we go. So does this give us the right numbers? 33210, 490, 424, 3455, and 401. Hell yeah. Hell yeah. And so now we should just be able to go like 40 to index. Or I guess we just have the sum at the end here. It's like for sum. And we print the sum here. Like this? Yeah. Boom. And so this is now sum plus equals sums index. Sum plus equals mul's index. Boom. This guy needs to be a U64. And we got 4277556. All right. Fuck it. I don't know how I ended up spending so much time on parsing this time, but it is what it is, I guess. Let's save this as day 6 input. All right. It is what it is. It is what it is. Bing, bang, boom. That's the right answer. Let's go. Part 2, day 6. Okay, so what is part 2? The big cephalopods come back to check on how things are going. When they see your grand total doesn't match the one they expected on the worksheet, they realize they forgot to explain how to read cephalopod math. Cephalopod is written right to left in columns. Each number is given in its own column, with the most significant digit at the top, and the least significant digit at the bottom. What the fuck? What the fuck? Right to left in columns. So 4, 4 here, 431 623. Jesus Christ, my dude. Here's the example worksheet again. Holy shamoly. Okay. So, oh my god. So this just now we're back to the like this is like not a memory friendly way to solve this. Right? It's like fucking impossible now. Because you do just have to read like entire column at a time. But we do now know, which is interesting, that the columns have to be aligned for this to make sense. Right? You can make it memory friendly? I don't think so. I don't think so because each number here, I mean, let's think about this. Right, like hold on, let's look at this. Like this is all one operation, right? And each number is like one column like this. So I guess technically you could do each how do I say this? You could sum each column independently. Right? Like here you can get 3 plus 2 plus 8 is what, like 14? Then this is 10, this is 17. And you can do the carries at the end, maybe? Maybe? If you did something like you represent, you allow, yeah, you parse each digit separately. I think. So then you have like a grid here that's like you have a grid here that's like each, I guess it's like the height of this is number of digits, right? Digits, and the width here is like result, like num answers, right? Something like this. And so yeah, there's something here. Which digit is like most significant? Top. So once you finish, so you're adding like most significant digit, most significant all the way down. Boom, 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 boom. Right? Each row. So if you have carry, you might have to propagate the carry multiple times because you're reading top to bottom. Can you read it backwards? If you read the file backwards, then carry propagation kind of like comes for free, I think, but I don't really know if that's like reasonable. Reading line by line backwards, if you assume that you can fit a line in a like each line in a buffer, which I think is like reasonable, then you can read each line forwards but still process from least significant to most significant digit, which is kind of nice in some ways. I kind of like that. I don't know if you can like seek backwards like that though. You definitely can if you mmap the file. Can you like read file backwards in Linux? Like, is that like a Linux Linux read file backwards? You don't know if you can seek? I know you can seek. What I don't know is reading characters backwards character by character is presumably slow. Right? Like, I'm trying to get it so that as I seek backwards, like, you kind of want the cache lines to line up properly, I would think, in some way, right? You want to make sure that like I don't know how to like say this. Like, you want, I think that like oh, I guess I know that I have a buffer size. And so I can just seek backwards by the buffer size and then fill the buffer that I'm working with. Yeah. I guess that's the answer. Uh Seek as a scholar, cache line is fucking gone. Yeah, I understand that. I understand that. Cache line was like the wrong thing. I was trying to say that like as I'm iterating backwards, I want to be sequential in memory in some way. M mapping is fine as well. Read forwards, parse backwards. I mean, only if I read the whole file into memory once, which is maybe fine. Maybe we just do that. I'm like okay with that. But I think that you could do something. You could do something where you like read backwards in chunks and then like do whatever like you were doing the normal way. Like yeah, let me think about this. So I have a file like this. Line lengths are known also, which is kind of interesting. We can abuse that. Right, we know that every line is the same length, right? Cat day 6 input. And then do like I guess we want to do like Python with open day 6 input text as f data equals f read, and then data, is there like split lines for x in this, print len x. Yeah, they are all the same length. They are all the same length. What's wrong with reading forwards? I think that if I'm reading backwards, I get to start processing at the smallest digit, and I know what operation I have up front, which I think makes everything easier. I think. Because then as I go, like, yeah, I'm pretty sure that that's how, like, when you do math in school when you're like 10, you know, you start at the lowest digit and work your way up so that the carries can like propagate nicely. Is it easier to start processing the most significant first? I don't think so. I could be wrong here. Why do I think that I have to start lowest digit first? That's a good question. Can we do some math by hand? Like, if I'm doing 356 plus 195 or something. So if I go top to bottom, I end up with 4 here. Then I come over here. This becomes 40. I multiply my existing answer by 10, and then I add in 14. Oh, which is fine. And then I multiply by 10, and then I add in 11. Yeah, I don't know why I thought that I had to go the other way. I guess just because when I do it in math by hand, it feels like that. But there's no, you're right, that there's no reason that I can't just do it top to bottom. There's a lot of effort just to not ask the kernel for the page file buffer. Stop telling me I'm having fun wrong. I want to do it this way. This is the point. Mister, the first message in chat today was you saying, stop telling me to have fun wrong. Or stop telling me I'm having fun wrong. You're doing it. You're doing the thing. I will never not tell you you're having fun wrong. Yeah. Okay. I guess I'm an idiot. I thought that I had to go bottom to top because I don't know why. Probably because, like, when you're doing it in one pass, the carrying's easier if you go bottom to top when you're doing it by hand. Is that why I thought that? Because then you can do, like, you can go, like, 1, 1, carry the 1. This is 14, 15. You carry the 1, and then you get, like, maybe that's why I thought that. So I guess I'm just a fucking idiot. And top to bottom is fine. Now, the only question is, I want to get the operators first. I do want to get the operators first this time. So let's do this. So we know each line has the same length, right? So what we can do is we can read. Can I scan like reader interface scan? Is there like a discard delimiter? Here we go. Inclusive? Okay, we'll do this. Line length is this. Line length is this. Reads until the stream until a specified byte is found, discarding all data, excluding the delimiter. Number of bytes returns the number of bytes discarded. I think I want inclusive. Like this. Then I want to see, I want also, like, can we get the length of this thing? Can we look at, size here? And I know the file size could change, but fuck me if that happens. This man slaps 2 4,000s. Shut up! Shut up! But 2 4,000 length U64 arrays but won't read a line of 4K characters into a buffer. That's right. That's right. Yes. Yes and true. Okay, so I want to, like, maybe reader seek to size minus line length. And then I want to do something that's like, also don't forget that the buffer's already 8K. Yeah, well, okay, for the record, I'm trying to write it in a way where the file size doesn't matter. That's what I'm actually trying to do, right? He refused to even use his buffer. Yeah, yeah, true. Because I like the idea that the file could be anything. You know what I mean? I like the idea that it could be any width, any height. Okay. So then we can read the operators. Which I guess we have here. So here we're trying to go. Look for a star or a plus, or else fill more, otherwise freak out. Then we have operators somewhere. Fine, fine. You know what, you guys? You fucking assholes. You fucking assholes. Fine. We'll do it your way. We'll do it your way. We'll fucking use an allocator. I guess we can do, like, ops is, I think we learned the other day that you can use an array list uh, with uh, with the page allocator, which is kind of fun. So I don't have to like pull out my own fancy allocator or like initialize an allocator or anything. So we have add mul, and I guess technically this could be a bit set. Right, you could, but fuck it, we'll do it this way for now. Imagine needing an alligator. Yeah. Old Sparrow would never have allocated. Shake my head. Yeah. Get fucked me, I guess. Vowels, and this is gonna be U64s. Okay. And so as we rip this shit, when we see a plus, we're gonna say operators ops append what is it? We need the page allocator and add, and then we have vowels append 0, and for multiply we have mul and 1. Wait, is that right? I'm not sure about this. I think it's also 0. I think. What happens when you're doing multiply? Hold on. How do you do multiply again? 25 times 50. Or 51. You do like 1 times 25. You do 1 times 25 plus 10 times 5 times 25. So 125 times 10. Oh, fuck me. Oh, fuck me. Wait, this isn't easy anymore. The summing was easy. The multiplying, not easy. Not easy. Oh, fuck me. Can't do basic mul. Wait. So can I do this in one shot while on multiply? Hold on. So then, wait, hold on. So then, if I have like 5, 6, 7, 8 times 1, 2, 3, 4, it's like every digit in the second one has to be multiplied by the full thing in the first one, right? There's no trick. What's the trick here then? Does that mean I'm fucked? Does that mean I am fucked? Just have an array of numbers? No! That's not the point. I want to know if there's a way to do it without just storing everything. That's the fun part. I mean, this guy's saying he has an answer, which is just like already a lot of information. He says you can do it in a memory efficient way, which is like now he's fucking now I need to find it. Okay. Interesting. So okay. You have transitive properties with multiplication though, right? Like A times B is the same as B times A. A times B times C is the same as C times B times A, which gets us somewhere, right? it means that you like, can you break this down in a way where you're like, okay, hold on. So 5, 6, 7, 8 times 1, 2, 3, 4. This is the same as 5, 6, 7, 8 plus or times 4 plus 5, 6, 7, 8 times 30. Right? Because this is the size that you can split this up as 30 plus 4 times 5, 6, 7, 8, right? Which means that maybe you can break this up further. Right? So then you like, okay, so you could do like 30 plus 4 times 5,000 plus 600 plus 70 plus 8. Does that get us anywhere? For if we're parsing like digits by going digit by digit? No. That doesn't help us because this is the same problem, right? The same problem here is that when you expand, the 4 has to hit all of these. Yeah. Right, in terms of A, B, C, D, E, F, G, H. I mean, that's kind of what I'm doing here, just with numbers. Is there something? There's gotta be something. You gotta store some numbers, but you can limit that. Yeah, I guess. Hold on, looking at the format again. Okay. So, okay, do you have an answer that's better than storing like how do I say this? Like I can just read all lines at a time. Like I can kind of step um I can step like one whole column at once, which isn't like ideal. But like there's something here where no, I don't have a good answer. I don't have a good answer. Interesting. Interesting. Yeah. Okay. So thinking again. Thinking again for multiply. What is like the sequence here? It's dude, what are these numbers? This is 20 this is 32 32 581 and 175. Okay. Now, yeah, I don't see a way to not store like you have to go through this whole thing at once, right? Am I crazy? You can go through the columns once and predetermine max op width. Where op width is right. Right. Because you know that you have 4 digits here, no matter what. And so does that help me in some way? It means that you only have to buffer 4 numbers. But you have to buffer those 4 numbers once per operator. So do you have a solution that's better? That's better than like are you processing kind of like this like how do I say this? One operation at a time? right? So you like seek the first line for the for the 4 digits, then seek the second line for those digits, seek the third line, and then do the multiplication. And so then you're only buffering the like you're only buffering a few numbers at a time, but your read behavior is really shit, which is like maybe fine. I guess there's probably also something there where that's how I did it. Yeah. Okay. Maybe that's fine. Maybe that's fine. I was thinking like I wanted something where you could do like single pass. Like our solution to the first problem felt elegant in that like you could read it all in single pass sequential memory access and not store a fuck ton. I'm struggling to find a way with this problem where you can hit the two same constraints. It feels like you either have to have a shitty read pattern or store a lot of shit. Those are like the two things I can think of here. The non-memory efficient way of storing every number than doing a SimDMAT autoplay was faster for me. Yeah, that makes sense. That makes sense. Okay. So as far as I can tell reading this, there's no perfect answer. You have to pick one. And so I feel like I would pick the shitty read pattern. And so now I'm way more willing to say, fuck it, we read the whole file into a buffer and then work on that buffer because I just feel like that'll be easier. Fine. Okay. Then let's fucking rip it. Read to end Alec. Okay. Data. It doesn't count as allocation if you just embed the file at compile time. He's a genius. Okay. So then we still want to do something where we grab the line length here. So this is stdmem index of scalar on the data. +1 here? I think +1. Then we have num. I think what we do is we like look at the last line. So like we have like op x start. And we do something like we look at like the last line, I guess. Line len onwards like this. I guess this is our ops. And I guess we could say like op x end is ops of something like this. So we're looking at like data from the next character on, and we're looking for anything that's not a space, I think. Okay. And then, so I think it's like, we have like something like this. It's like plus space, 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 space times. And then the numbers are going to be like in here, right? So it's like number, 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 this is number as well, and then a space because there has to be spaces between the numbers. So then this is like num end is op x end minus 1. And then defer op x start is op x end, I think. Yeah, something like this. And so then what is the fucking number format again? How are these things stored? They're fucked, right? It's we have I guess nums is going to be like some amount of U64s or something. I guess you know that the maximum size, max number size is, never mind. Do you even need to buffer anything? If you do it the stupid way, you have like 369. I guess you can probably do something that's like while x is less than op x end. I don't know what to do with this yet. You can do like num digits is gonna be data len minus line len over line len. Right, so like get rid of the operator line and then divide by the line length. This is how many digits are in each number, which is gonna be something. Right? You have like you go number by number here, and you look at like you have this thing, and as we go row by row, we're doing num times equals 10, num plus equals the thing at this row. So this is like data at line len times y plus x. But this is a parsed int. Minus 0, I guess. Yeah, it's like something like this. Something like this. And then we have like our operator here. So then it's like val, so like it's like I guess we get the operator here. So this is gonna be data or like ops at op x start. And then here we like switch on the op. And we have like total here, I guess. Unsure. But it's like here, if you have plus, it's like total plus equals num. And if it's times, you have total times equals num. Else unreachable. Right? Something like that. And then we do x plus equals 1. You have to handle missing digits? No? Yeah, true. Yeah, so it's like var character is this. If c is greater than 9 or c is less than 0, let's crash. And then in the case where if C is equal to space, C equals 0. Something like that. Something like that. Okay. And then can we just do one iteration of this for a second? And I just want to also print out like this number here. And then total like this. Sure, fuck it. I don't know. Index of scalar. Sure. Var. Okay. Expected index of or else I don't know, man. What happens here? Why are we crashing? Hello? Unreachable at 83. That's right here, right? May I forgot a new line? Because it's a new line. No, wait, what is it? Am I stupid? 0. 0? Oh. There we go. Now this is integer underflowing. Because I'm not using C there anymore. Unreachable at 94 now. Can we print the op here? What's going on here? It's probably like a space or something, right? Yeah, so... Oh, wait, hold on. Is this a new line? It might be a new line. Yeah, it is. So if op is a new line, how the fuck did that happen? How is this operation a new line on the first thing? +1 here? Probably. Like the start of the line, I was going back by a line length, which was ending up at the new line, so I need to go past 1 or something. Something like that. Something like that. Okay, there we go. So we got operator star, total 0. So should there not be many numbers in this? So I got 100 here, which is good. That is the first number. But maybe op x end is wrong here? So here we need int from bool. Op is multiply, I think. So if it's multiply, then it'll become 1. Okay. So now we're missing the next digit iteration. So why is that? It must be op x end is wrong, right? End is op x end here. The first number is 1? First number is 100, no? Is it bottom to top? Wait, why is it 1? What the fuck? How is this 4 and this 1? Oh, spaces aren't zeros? Oh, what the fuck? That's crazy. Okay, so then here it's like if C is space, I guess we continue. Okay, that's better. Now, why aren't we like end is 1, which is a problem because we're looking for the index of operator. Like this should be finding the start of the next operator. And it's like not doing that, which is confusing to me. Can we look at std debug? Oh, data here. This should be ops. There we go. Okay, so we got 124 356, which is wonderful. Now, somehow this total is getting set to 0. Because the number, we're parsing one extra column, I think. I think we're parsing one extra column and it's ending up as a 0. Nice. Okay. So 124 356 is 8544. Beautiful. And now can we not break here? And let's just kind of see if that looks a little better. So we get 8544. 625 is correct. 325 3600 is correct. Now it's just the last column is fucked. So I think this or else unreachable here needs to be line len. And then if these things are right aligned, this has to be +1 for it to be correct, I think. 96. What the fuck is going on then? Op is a new line here. Oh, wait, hold on. Um, 431. So he sees 431 here. Does he see 624 somewhere else? Or 623? No. Interesting. Interesting. Where the fuck is this going? Ba-da-ba-ba-bum. So op is somehow a new line here. So that means that op x start is at a new line here, where op x start is the previous op x end. So I guess it's like, if here we have this is probably our exit condition, right? Okay, but we're still missing the last sum, right? This 1058 is not showing up anywhere in here. Which means that like we are getting the operators correct because the other guys are adding correctly. I'm actually confused. Can we look at the whole ops buffer here? Okay, so we have times, plus, and then a new line. Oh, the plus is directly against the new line here. Wait, how's that possible? Because that's not what it looks like here. Did I, when I copy pasted this, day 6 input example. Oh, my fucking, oh my god. My Vim save truncates lines. Xclip. XL. Can I copy this and do XL clipboard here? WL paste. Yeah, here we go. Day 6 input example. So now does this work correctly? Wait, what's wrong now? Now what? Now what? Now what? So now he is saying off rip. End is, wait, he's missing, oh, the -1 now is probably wrong. Yeah, there we go. It's crazy that it was like at all working before. So 1054, that's wrong now. So 8544, that's right. 625, that's right. 325, 360, that's right. But then we are seeing num 623 plus 431 plus nothing? Interesting. So we're missing the last line. Why? There we go. 1058. So here I was exiting a character early to avoid the space at the end of the line. But now that we're handling spaces correctly, we can just process that quadruple space thing as nothing and it'll kind of work correctly, I think. Because we never do the math otherwise. Okay. Cool. So now we should be able to just like... Wait. It's broken again? Our multiplies are wrong? Why? Because here, if num is 0, we have a problem. Never mind. We're not handling that case correctly anymore. We could do this, I guess. And then... here, it's like, if... Oh, I guess no. What we do is we initialize it differently depending on, if we... Yeah, you do have to do this, I think. If num else 1. Or I guess it's just like this. If num n. Because otherwise we times by a 0 because we parse no digits or some shit. Yeah, there we go. Gross. Gross, 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 gross. Why do editors love to remove trailing white space? I think I intentionally added that to my config. I think. So this is total. Bad names. But then we can do total plus equals total, and then write that shit out the end, I guess. All right. 3263827. 3263827, and then we swap this for our actual input. And we see if we get the right answer. Oh my god. Let's go! Yeah, it's fucked. That is a fucked problem. It sucks because it's like it's hard to find like the solution that is what I feel like is elegant. It's just hard to find in there. But I guess it is what it is. I feel like part 2, this feels like the first time where we've just like actually done the dumbest thing. This guy did an SQLite. That's crazy. Right? Like here, I just don't think that there's like maybe there's a more elegant solution, but I couldn't find it. I feel like what they want you to do is just transpose the problem. Yeah, I guess maybe you could get away with that, right? Like a transpose. I think you still have the same like memory access patterns though. I think it's kind of the same. All right, let's do day 7. And let's hope that it's easy. Let's hope that it's easy. All right, we thank the cephalopods for the help, and we exit the trash compactor because they said they were going to get us out. I feel like part 1 didn't lend itself to part 2 at all. Yeah, true. But I think that's fine, right? I think that like programming, you do end up in situations where you have to pivot, so it is what it is. Okay, so we get out of the trash compactor that's full of octopuses, and now we are in the familiar halls. Okay, cool. I don't think you need to link halls of a North Pole research wing. Based on the large sign that says teleporter hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto a large yellow teleporter pad. Yeah, dude, for real. I couldn't, yeah, I would want to get on too. Suddenly you find yourself in an unfamiliar room. The room has no doors. The only way to get out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke, which is the classic, you shorted something and it burnt, and so the smoke comes out. And it's like, no, the magic smoke that powers the computer. Since it's a teleporter lab, there are lots of spare parts, manuals, and diagnostic equipment lying around. After connecting one of the diagnostic tools, it helpfully displays the code. Oh no, which apparently means that there's an issue with one of the tachyon manifolds. Crazy. You quickly locate a diagram of the tachyon manifold. A tachyon beam enters the manifold at location marked S. Boom. Tachyon beams always move down. Boop. Tachyon beams pass freely through empty space, which are dots, and if it enters a splitter, the beam is stopped. Instead, a new tachyon beam continues from that immediate left and immediate right of the splitter. For example, here we come down, we go beep boop, we trigger beep boop boop boop, and then here this will come down, and this one on the right will make it all the way down. We probably want to make it so that, like, where is like the error? To repair the teleporter, you need to understand the beam splitting properties of the tachyon manifold. In this example, a tachyon beam is split a total of 21 times. Oh. Okay, so we're literally just fucking raycasting, right? We're literally just raycasting. So what's like the way I want to represent this problem? What is the way I want to represent this? Probably, so there's a couple things we could do. We could try to do the single pass reading approach again, right? In which case, at each line, we will store the indexes in the array at which there are beams, probably, right? Or we just have a buffer that is like on or like on off, right? Then as you read this thing, you check the splitter and you say, if I hit splitter, then you like alter the beams. What happens if like two beams collide? Do those merge back? So like this is 21, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, right? So there's more splitters in here. Oh, I guess but this splitter's not hit. So it's if here when we split twice here, these two got merged is the answer here. Okay, yeah, I think I will just, for the first thing, we'll try to do the single pass solution, which is store indexes, or maybe not even store indexes. I think I will store a row, like a bit field of if each position in the row has a ray on it, and then we just can easily flip the bits as we need. And as long as the rows aren't like insanely long, then that's fine. So let's do that. Okay. So F is open file day 7 input example. Like this, like this. Here is our reader buff, and we go hit me with one of these bad boys. I think that we want to read the line length first, or do a first pass, like first line read. I guess we can do first line read. Does it always start in this? Oh, it starts where there's an S. Is there many S's, or is there always a single S? At the location marked S. So there's a single one, right? So we read the first line. So we do like take delimiter exclusive and I guess technically you can do this. Line part 1 and line part 2. And then we say line len is line part 1 plus 1 plus line part 2. Easy. We make like a little bit set here. So let's make him, I don't know. That seems plenty big. That seems plenty big. Stood bit set. Static bit set? Sure. Let's do that actually. Var, like, what do you call this? Like rays? Ray position, rays, I guess? Rays, like, how do I initialize this motherfucker? Init empty, I think is reasonable. And I don't know why he is not happy here. So we have an array bit set here who has init empty. Yeah, he should. And so then I can, like, can I set value on index to bool? We can just call set. Raise set line part 1, I think. I think this is actually just, what was the other thing? There's like take, and then there was scan, like take, discard delimiter. I think it's just like this. I think. And then I guess we want to assert that raise, like that line len, is less than 128. Oopsies. Zig run day 7. I guess these guys do need to be tried, so true. And now they're like file not found, so true. Whoop. Day 7 input example. Oopsies. Well, we will call it too late. Day 7, it's a dot zig. Okay. So this is compiling. I don't know why my like language server doesn't like it, but whatever. And so now I guess we just go like while true. We do reader like byte get interface take byte. And if we are at end of stream, we're done. Else we have an issue. And we switch on B here, and if it is a new line, we reset something. If it is a dot, we do nothing. And if it is a splitter, we check if there is array there. Which, since it's not fucking resolving correctly, we have to check manually. There's is set here. And then there's also unset. Okay. So, if this is set, if raise is set, then raise unset index and raise set index -1 and raise set index +1. We probably want to do like if idx is greater than 0 and if oopsies. And if index is less than line len here, right? Probably. Sure. And then else unreachable. And then maybe for now, can we render the board as well? So can we do like something like this to debug print a new line? Just to make sure that we get it right. Maybe we do, I think that's fine. And then can we render here? I guess for any other guy, it's like if raise set index, we print a beam. Else we print just the character, right? Which means that we actually can get away with this now. I think. Is set, oops. Okay, bad news bears, this is never happening. Also, index is not being incremented here. I guess there's a better way to do this, but whatever. Okay, close. Right. So here we only want to set adjacent. I mean, this might be correct enough. No. So it's because like we're setting the thing to the right. But we're not rendering the one on the left, which is fine, I think. Left side seeming bad. Well, it's because like we don't know that this guy has a beam on him until he's been split. But I think that for now, we can also just assume that there will never be like two directly adjacent splitters. You know what I mean? So I think that what we'll do here is like for now, we'll just do like this. Last was splitter. Maybe it's fine. Yeah, maybe we do this. Assert no adjacent splitters. No adjacent splitters. And then I think this needs to be like file reader, actually. Because we have to be able to seek at the end. If built-in is import built-in, optimize mode. I guess if not debug, we return. Then we do can we like reader pause? Okay. So what do we want to do? We want to go like var last was splitter is false while reader interface take byte while true. B is this. Catch E switch E. Error end of stream is a break, else return E. Okay, and if so I guess it's like switch B. And if it's a splitter, last was splitter is true, and then if last was splitter, unreachable. Oh, there we go. Last was splitter is false here. Bang, bang, boom. Now we have some confidence that if there were two adjacent splitters, we'd crash. I think. There is no such case. There is no need to assert. That's the point of assertions, no? So let's just do like a little this guy, and then that assertion should fail. Yep, okay. Cool. There is no such case. There is no need to assert. That's just funny to me. It's like we're trying to gain confidence that that's going to keep being true as the data changes. So it looks like we're chilling. Can we add up all of the fucking collisions now? So var splits 0, and then here we say split if is set splits plus equals 1. And then we can say this many splits. Okay. 0. That seems bad. Also, like, why aren't we fucking running the fucking thing anymore? Is it this assertion is causing it to not run anymore? But at the end of this thing, we seek back to where we were when we started, no? Does this not invalidate the underlying buffer or something? You have an early return? Only here, only on error. But that's fine. Like, the early return is if we error out. So if we errored out, this would cause problems. What the fuck? $256. $256. Yeah. So wait, what's the problem? Oh. It read the whole input. I see. This is the wrong thing. Is it logical pause instead? Yeah. Okay, that's better. That's better. Okay, there we go. So now we can do this with the real input. Get my puzzle input. Look at that pretty Christmas tree. Day 7 input. All right. Unreachable code. So how many lines is there? Max line len is this. Let's use this here and here. Okay. Zoom out. I mean, just staring at it, it looks correct if I just like am like eyeballing it, right? Like that looks correctish. What was the issue? It was that I was so you're talking about the seek issue. So when you're using like buffered reader, there's kind of like where in the file you've read up to and where in the buffer you've consumed from. So if you use reader.pause, this is like how much of file has been read into buffer, right? And like logical pause, this is like how many bytes have I consumed through the buffer. You know what I mean? Okay, let's see if this is right. Let's see if this is right. That's the right answer. You get 1 gold star. Bow, 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 bow. All right. Day 7, part 2. Let's get crazy. Let's get crazy. With my analysis of the manifold complete, I begin fixing the teleporter. However, as I open one side of the teleporter to replace the broken manifold, I am surprised to discover that it isn't a classic tachyon manifold, it's a quantum tachyon manifold. Double slit experiment or something, probably. With a quantum tachyon manifold, only a single tachyon particle is sent through the manifold. The tachyon particle takes both the left and right path of each splitter encountered. Since this is impossible, the manual recommends the many worlds interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left, and the other timeline, the particle went right. To fix the manifold, you really need to know is the number of timelines active after a single particle completes all of its possible journeys through the manifold. Okay. How is this different? It's different because if when we were masking before, we were saying like if there's a splitter and it goes left and right, it's before it was like the two lines like collide into one, and now it's like those have to stay as independent lines. So instead of this bit set here, we can store a count here, and every time we hit a splitter, we add the count of beams that had hit this splitter to both sides, right? So here, here I think we can still count. We can still do the single path split check, but it's just we count how many beams at each line. I think. So this is now going to be a array lists of surely U16 is good enough. U8 is probably good enough. And then we want to do like init buffer of raise buff or something. That we don't need an allocator. Var raise buff is max line len u16s, and we're going to initialize these to zeros. Then we set, I guess this is just actually more like this. Raise buff from 0 to line len. There we go. And then raise at line part 1 plus equals 1. Now, every time we do this raise set and raise unset, I think we go raise, index plus 1 is equal to raise index, minus 1 here, plus 1 here, and then here, now we set raise to 0. Like this. Then here, let's just say if raise index is greater than 0 for now. Is set. Was that left somewhere? If raise like this. And then it's not equals here, it's plus equals actually. Okay, so integer overflow. Can we do it on the example? Which we named .zig because we're idiots. So we see 21 here, which is wrong, surprisingly. Why? Why? Because splits here needs to be plus equals raise index. 39, that's close. We're definitely close. We're off by 1 here. Interesting. So if a ray comes in, one ray comes in here, he splits into 2 timelines. Then for each of these, okay, so if it's like, hold on, 1 thing, do, 1, 2. So this is 1. Now this is 2, right? 2 timelines now. Then this is 4. The answer to this is 4. So this should be 1 comes in, and he splits into 1, 1, and this counts as 1 here. Then this counts as 1, 1 hit here. We need to count the output at the bottom. We need to count the output at the bottom of how many rays there are at the very end. So here I think that instead of summing the splits here, what we do is we iterate the array at the end. For rays, total is this total plus equals v, and this should be like this. 40. There we go. There we go. There's 1 time at the base, so plus 1 at the start. I'm not 100% that that is the correct answer, because I feel like there's cases where, there could be like lots of overlaps in a way that is like not accounted for by that 1 at the start. I don't really know why I think that. It's just like a vibe I have, and so I would rather add up at the end than add the 1 at the start, because I feel like that's going to be wrong. We could also compare our answer at the end. We could compare this. So we could do what you guys are suggesting and what I'm suggesting. So we initialize this to 1, and then we have splits plus equals 1 here. Plus equals raise index. And And then we can do an assertion here that total is equal to splits, right? So that's true for the input example, but we'll see if it's true for my example as well, or my input as well, I should say. So this is day 7 input dot text this time. Right, we're overflowing. So U16s and should go up to U32s. Wait, really? Still? Really? That's crazy. Holy fuck. Okay, so it didn't crash, so I guess the answer, you guys were right. But to me, it felt wrong. And holy fuck, that's a big number. That's crazy. Dude, computers are so fucking sick, by the way. Like, the fact that you can count that high in that short of time is pretty fucking cool. That's pretty sick. Computer's kind of OP. Dude, okay, dude, I was so fucking mad yesterday. I was trying to order some Uber Eats on my phone, and it literally took 10 seconds from when I clicked a button on the website to when there was any visual feedback. 10 fucking seconds. Dude, that's an impressive delay because that means that it was buffering the input for 10 seconds. How can you be 10 seconds behind? Like, it's like I'd be more happy if it just lost the input. But somehow it's like trying its hardest on my fucking phone to like click up to be like to post a JSON like, hey, like I'm going, like not even send the thing, just be like, hey, I just want to let you know that I'm going to try to send the thing. 10 seconds. Too much food? It was one thing. It was the only thing in the cart. And so, anyways, the point is like computers are so fucking fast. Like this is honestly like incredible. I know it's like not actually that incredible, but it's like pretty crazy, right? That like you can, you know, like the fact that we need a U64 and you can basically like instantly get the answer. The computers are so fucking fast. We're in debug mode. We're doing a bunch of printing in between. We're doing a bunch of like dumb shit, right? And it's still like instant. And then I use software, and it's like taking 10 seconds to press a button. It's like, what the fuck are we doing? How the fuck are we managing this? And like, how much is like Uber market cap? Like, how much is this fucking company worth? This company is worth $190 billion and they can't fucking add a button to a website? Like, what are we doing? Like, you know what I mean? It's crazy. It's crazy. But also, computers are so fast. Like, it's like incredible in both directions. Anyways, we got sidetracked. I just wanted to get, I was just mad. I'm just mad. But Advent of Code, pretty exciting. We fucking, day 6 was hard, I think. And I don't know if day 6 was actually hard versus like we were overcomplicating for ourselves. We were definitely overcomplicating it for ourselves. But so far it feels like day 1 had hands and day 6 had hands. Everything else has been pretty straightforward, but definitely fun. Also, look at this beautiful tree. Look at that thing. Beautiful. Christmas. Just got day 6 part 2. Took 1.5 hours. Yeah. All right. Cool. I think we got there. Thanks for watching, guys. If you like what we saw, we stream most days. We aim for 12:30 to 4 Pacific time. Today, once again, I just forgot that if I do double Advent of Code, it's not like 4 hours of stuff. So a little short stream today, but we'll be back on schedule tomorrow. I think I want to work tomorrow on our like that VLC plugin again, and then a little bit of Advent of Code day 8. We're also working on like a window manager / like compositor, basically like, you know, the thing that's displaying these windows. We want to make one of those. So if you want to see all that, swing back by. We'll probably not be back on the window manager until after Advent of Code ends, but I think Advent of Code ends in a few days, so we should be back soon. Patreon, YouTube members, Twitch are all good places to support if you want the stream to continue happening forever. Otherwise, I think that's it. YouTube, peace out, and Twitch, let's find someone to raid.